All right. So this first page, I'm not the one that made this one. So I'm not sure what they mean here about exponents. So I wouldn't worry too much about exponents, but I would focus on where it says algebraically and graphically. That's where you have to identify if a function is even or odd. On an even function, okay, algebraically, if you look at the actual equation of the function, the whole point is that you would take anywhere where there's an x, and you would replace it with negative x. That's how you test. That's how we're going to test to see if something is even or odd. So if you have an even function, every term remains the same. Even after switching x to negative x, every term stays the same. On an odd function, every term changes sign. And if it's neither even or odd, it's just none of the above, not applicable. Or here, better yet, that's right, none of the above. Graphically, an even function has y-axis symmetry. So if you were to draw like an imaginary line down the middle of the y-axis, each side should look like a mirror image of the other side. Another way that you could check by the points on the graph is that, for every x and y that you find on a graph, you should also be able to find negative x, y. So what I'm telling you there is, like, let's say you have a graph that has 2, 5 on it, 2, 5, and it happens to be an even function. What point should also be part of that graph? If I just said 2, 5, if a function has 2, 5 and it's even, it should also have negative 2, 5, if it's even, if it's going to be even. A odd function has what's called origin symmetry. Now, origin symmetry is where that mirror line, that line of reflection, the axis of reflection, is at the equation y equals x, which is just a diagonal line that goes through the origin. But sometimes that's hard. Like, you can look at it like, oh man, I'm not sure. Is that symmetrical? Is it not? If you're not sure. Here, for every x and y, you should also have negative x. So if 2, 5 is there, then negative 2, negative 5 should also be there. That's if you're going to have an odd function. And if it's neither, it's just none of the above. So I had told you today we were going to do an activity, but the thing is, it wouldn't have taken up the whole period. We would have finished it too quickly. So the activity comes at the end. Hi. Yeah, there's the pass. Just go one at a time. Okay, don't worry about that beware of constants thing. I don't know. I didn't write that. Hi, Antoine. So don't worry about where it says about constants. Let's just do the examples and then hopefully it'll make sense. Okay. So the first one. How can I check to see if this function is even or odd? Well, instead of an x, I'm going to replace every x with a negative x. So instead of x to the third, in parentheses, negative x to the third, minus, because the minus still has to be there, and then a negative x. Everything looks exactly the same, except I took out just the x's and replaced them with negative x's. The only thing up here that is not an x is the cube and the minus. And if you see here, I still have the cube and the minus. I just changed the x's with negative x's. But then I need to simplify. Well, when all you change is a positive to a negative, when you simplify, the only thing that could possibly change is the sign. It shouldn't be like the numbers, whatever numbers are there should still be there, if there are any, but the only thing that could maybe change is the sign. So let's see. Let's look at the first term. If I take negative x to the third power, what happens if you take a negative base to an odd power? It does not become positive. It does stay negative. A negative to an odd is negative. A negative to an even is positive. So this will be just negative x to the third. On the next term, you don't really have to worry about exponents. But what's a negative negative? Positive x. So now I am done simplifying. Now all I need to do is compare. If I compare the original function with what I ended up with after changing the signs, how do those compare? We're looking for two possible things. First of all, does it look exactly the same as it did before? Does it look exactly the same? No, definitely doesn't look exactly the same. So that means it can't be even. Is it the same except for the sign thing? Every single sign has to be different. Is every single sign different? Yeah, there was only two terms. Before it was positive, negative. Now it's negative, positive. Because of that, this is. If neither would have applied, then it would have just been neither. Okay, let's look at the next one. Let's evaluate f at negative x. There's only one x here, so I'll change that to a negative x. Make sure you're using parentheses and then put a plus 1. But we have to simplify. What is negative x squared? If you take a negative base to an even power, what happens? It does become positive. I am now done simplifying. There is nothing else that can be done there. How does my new function compare to the original one? They are exactly the same. And because they're exactly the same, what does that tell you about the function? It is even. Even Steven. Number 3 should be pretty obvious. By the way, if you have any questions, say something. Kiara, any questions? Golf? You know that golf spelled backwards is flogged? If a graph were to be even, it would have y-axis symmetry. So if you were to draw an imaginary line on the y-axis, either side should look like a mirror image of the other one. This pretty obviously does have that, so we can tell this is going to be even. If it were odd, just for fun, so you know, if it were odd, it would have origin symmetry. Origin symmetry is on this equation, y equals x. So basically, like everything on this side should look like that side. This does appear to be even, but if you're ever not sure, do the point check that I gave you. Pick any random point. You might want to pick more than one point just to be safe. But like here, look, this has 3, 3. So what other point should be here? Negative 3, 3, because I told you up here, for any point, negative xy should be. So you just change the sign of the x. You can also pick a point on the left to see if that also checks out. Here I have negative 5, 5. If negative 5, 5 is there, what also should be there? Change the sign of the x. if negative 5, 5 is there, that point is negative 5 comma 5. And if it's even, I told you that 5, 5 should also be there, and it is. So we've tested it out, and it appears that this is even. Hey, what happened over here? Okay. Now look, number 4 here, that's a little bit less obvious. It does not appear to be even. I could rule that out because I mean I don't even need to draw a line. I have the y-axis there, and the left side of the y-axis clearly does not look the same as the right side. Now I could draw that axis, so like I would start like for instance at 5, 5, and I would go down to like negative 5, negative 5. That's the equation there. And it sure does not look like, this side over here, should look like a mirror image of that over there. And that doesn't appear to be the case. So it looks to me like it's going to be neither. But at least for me, I always it's harder for me to visualize odd functions. So just to be sure, I would prefer to do the check with the points. On an odd function, you're supposed to change the sign of both. So if, like for instance, I don't know, it looks like 0, negative 1 is there. What else should be there? Yeah, if 0, 1 is there, that means that if 0, negative 1 is there, then 0, 1 should be there. And 0, 1 is not. So what is this going to be? This is going to be neither. It is a function because it passes a vertical line test, but that function is neither even nor odd. You getting all this down, Brandon? All right, let's let you guys do a few of these. Go ahead and do 5A. Tell me what you get. Do 5A. Once you get 5A, let me know. Jada, what'd you get? Meaning, so what's it going to be? When you take out the x and replace it with a negative x to the fourth is x to the fourth, so Jada was correct. It looks exactly the same. Therefore, that is an even function. Anybody have 5B? And you got 5B? Yeah, is that the same one? Do we have the same one at the beginning? Oh, we had minus x? Now this is plus x. All right, let's see. So if we replace the x with a negative x plus negative x, that would be negative x to the third minus x Yes, you are correct. Every sign is different, therefore this is odd. Does somebody not named Jada or Ann have 6A for me? Should be one of the easier ones. Huh? You say even, let's see. If I have a negative x to the third, is that really gonna okay? It comes out. Negative x to the third is negative x to the third still, but then the negative makes it positive, so that actually should be even. But you know what? I want to look at that because how can that be? Oh no, sorry, no, that's no, not even, not even. No, okay, Martha, you confused me. No, even would mean that the signs are the same. The signs are not the same. The signs are different. So what is it? Odd, yeah, it's odd. Okay, somebody not named Martha or Ann or Jada. Want to tell me the next one? This would be also a pretty simple one. Even odd or neither. Okay. Five times negative x to the third. Negative x to the third remains negative x to the third. When you take a negative to an odd, it stays negative. And then negative times positive is negative, so we end up with negative 5x to the third. In order to be even, these two have to be the same. They're not the same. They're different signs. Caleb, you want to do 16? What is it? What do you get? Tough one. Brandon? Nah. Caleb didn't answer, so you don't want to answer either. Brian? Nah, too hard. You already answered Jada. Ingrid? No, it's going to be even when you think, what is negative x times negative x? A negative times a negative is a positive, so it just stays x squared plus 4. When you compare x squared plus 4 to the original one, they're the same. When it's the same, it's even. Marquise, 7A. You got what? You say odd, let's see. Negative x to the third minus negative x squared. Negative x to the third is negative x to the third. Negative x squared becomes positive, but that negative is still in front. Are the two the same? What I ended up with, is it the same as what I started with? Definitely not the same. But is every sign different? No, only the first sign is different. So this one's going to be neither. Read 7B. You say odd. Let's see. So it's negative x to the third plus 2 times negative x. All I'm changing are the x's for negative x's. Any other sign has to be there. Negative x to the third is still negative, but when I combine it with a negative in front, that becomes positive x to the third, and then positive times negative is negative. Every sign is different, so Ree was correct. This is odd. Lan An. How about 7C? Even, odd, or neither? You say what? Odd. All right, let's see. negative x to the third plus 4 times negative x plus 1. So we got negative x to the third, that stays the same, minus 4x plus 1. Are those two the same? No, they're not the same, so it can't be even. Are the signs all different? Now the one stays the same. So it actually, this would be neither also. In order to be odd, every sign has to be different. Sam, I'll give you an easy one. 8A, even, odd, or neither. It is even. It should be pretty obvious. This does have y-axis symmetry. If you weren't sure, you can check the points. Ooh, a little more challenging one. So we'll go Kiara then. Even, odd, or neither for 8B. Correct. And you want to help her out? It does appear to be odd. Now, see, there's a couple ways you can check for odd. One would be is if it has origin symmetry. Sorry, that's a hand. Better way. If the top part is the exact mirror of the bottom part, but that's hard to check sometimes. So what I like to do is I like to look for the points that are obvious. Like this is obviously passing through 0, 0. This is looks like it's pretty obvious that it's passing through -2, -5, and it's pretty obvious that it's passing through 2, 5. If this were odd, I should be able to pick any point, and for any point x, comma y, it should also include -x, -y. Well, with the 0, 0, yeah, that flies because 0 is neither negative nor positive, but let's focus more on the 2 and the 5. For any point, 2, 5, I would also have to have the opposite signs, and it does. Let's say it would have had, just for pretend purposes, let's pretend it would have had to have the point -5, comma 7, and it had to be odd. What point would also have to be there? In order to be odd, what point would also have to be there? Change the signs of both numbers. 5, -7. Thank you. It's not rocket science. J Money, you want to do 9A? It is going to be even good. That does look symmetrical over the y-axis. Caleb, you want to redeem yourself on 9B? We'll be back to writing love notes? No. Yes or no? You just guessed odd? Well, it doesn't appear to be odd because if I were to draw that, if I were to draw a diagonal where y is equal to x, like y equals x means that it has like 0, 0, 1, 1, 2, 2, 3, 3. Those are the points that the mirror goes through. The top part of that mirror looks nothing like the bottom, so it's pretty obvious that it isn't. But if you're ever not sure, pick any point that it is obvious that it's going through. This pretty obviously looks like it's passing through -2, comma 1. And based on what Marquise just told you, in order to be odd, which is what you said, what point would also have to be there? At 2, 1, 2, -1. And if I look at 2, -1, there's nothing there. So we know it can't be even. That's a little easier to tell visually because in order to be even, the left and the right side have to be the same. It doesn't look even. It can't be odd. We just proved now, so this would be either. B Money, how about you? You want to do number 9C? Now that Caleb got one, you want to do? Huh? Okay. And that actually does look odd. You can do the origin symmetry thing and see if that looks the same. But even that's confusing for me. Like even I struggle with that sometimes. Like, wow, are they the same? I'm not sure. So you could also check points. Let's see some points that look pretty obvious. Okay, here's one that looks pretty obvious. It looks like 2, -2. If 2, -2 is there, what else should be there? What else should be there? Have I heard from you? You're gonna go next. Yeah, -2, 2. 0, 0 still there, which it would have to be there. Oh, actually, I want to say yes. I want to say it has to go through the origin, but maybe it doesn't. Maybe it's a counterexample where it doesn't. Maybe it's some other type of function. Some type of maybe like a rational function. Any questions there? So this was the activity that we were supposed to do then. And if you go to the next page, like that was supposed to be a cut and paste thing, and you have to use the glue, and you put it in columns and everything. I'm not really good at that, so I was just gonna have you like, write it in and stuff, like work it out on the side and write it in. So that's just what we'll do. All of these are algebraic. This one we already saw today. Was this the first example that we had? X third minus x? Yeah, so we already know this one's going to be odd. We did this one already. This one's odd. Just look at the work if you want at the beginning. Okay, this one's new. Now, Kai, is that even, odd, or neither? You say neither. Let's see. So is negative x to the 5 minus 3 negative x squared. So this stays negative x to the 5th. That becomes positive, but it still has a negative 3 in front. So you are correct. This is going to be neither. It's not exactly the same, and it's also that the signs are different. Okay. The next page I have, look, this I seriously doubt this is going to show up on an Algebra 1 test. I'm pretty sure that this is just part of the worksheet. But just in case, this is just memorization. These are called trigonometric functions. You'll see these next year in geometry. You don't even have to really worry about what they mean right now. Just know what they are. This first one is it's called sine, even though it looks like sin. Cosine and then tangent. It's just memorization. There's no testing here. You don't have to test anything out. Out of all of these, cosine is even. The other two are odd. Odd, even, odd. Just in case. You'll see those starting next year in geometry and then algebra 2 and everything after that. But I wouldn't worry too. I doubt this is going to show up on a final exam. Any questions there? Okay, this is maybe you heard me mumble the word a rational function here. This is a rational function. Anytime you have a fraction that has a variable on the bottom, that means it's rational, but we can still test it the same way. So let's check f at negative x. So we will go negative x squared minus 2 times so minus 2 times negative x over 3 times This is another one that I do not think will show up. I do not think they will give you any of these. Okay, so this is going to be x squared plus 2x over 3x to the fourth. When you take a negative to an even, it becomes positive. Or does it look exactly the same as when it started? No. Are all the signs different? No, just the 2x. Shobi, I haven't called on you yet. Want to do this one? Come on, Shobi, please. Go ahead, Martha. Martha says even. Let's see if we change that to negative x. The square makes the negative positive, and it does end up looking the same, so Martha is correct. 3 cheers for Martha. Hip, hip, hooray. Hip, hip, hooray. Hip, hip, hooray. Come on, Kiara, I still want one from you. You say this one's neither? Let's see. Equals 5 times negative x plus 3. So that's negative 5x plus 3. The 3 stayed the same, but the negative 5x didn't, so Kiara is correct. This is neither. You say neither, I say neither. All right, Jaden, I know you've been excited. You want another shot? Even, odd, or neither? Yeah, that looks like it's going to be neither. There's all sorts of different exponents there, but let's see. So it'd be 6 times negative x to the fourth minus 3 times negative x to the third minus negative x squared minus 4 times negative x plus 7. So this is the first one to the fourth becomes positive. This second one originally becomes negative, but because of the negative in front, that becomes positive. So positive 3x to the third. The second, the square becomes positive, but it has a negative in front, so that becomes negative. Then this becomes positive, and the 7 stays the same. Is that exactly the same as the original? No. Is every single sign different? No. So, Jada was correct. Jada, we trust. Go ahead, Jason. Negative x to the third becomes negative x to the third, but minus 2. Does it look exactly the same? Doesn't look exactly the same, so it can't be even, Jada. Is every single sign different? No. The constants stay the same. Yes, ma'am. When it's what? An odd exponent keeps a negative negative. An even exponent makes it positive. So this one's going to be Sam I am, even, odd, neither. Even, odd, or neither. Odd, there was only one term. That only term that was there changed signs. Odd. Nakai, even, odd, or neither. You say what? You say even? Or you say neither? Alright, let's see. 2 times negative x to the 4th minus 3 times negative x squared minus 6. So this 2 stays the same because this becomes positive x to the 4th. This becomes positive, that the negative x squared becomes positive because of the square, but it still has a negative in front. So that stays negative 3x squared minus 6. Looks the same to me. Ergo, vis-a-vis concordantly. Go ahead, Martha. Kiara? Kiara wins. You said neither, right? Negative x to the 4th minus negative x squared is positive x to the 4th. Jada, you were just asking about the exponents. An even exponent will turn a negative into a positive. Yeah, well, I haven't finished yet, but yeah, 4 is an even number. Negative x squared, the square turns that positive, but that negative 4 is still in front. So when you compare the two, they look the same. Right. Even, let's see. Negative 2 times negative x squared. The square turns the negative into a positive, but that negative 2 is still in front. They end up looking the same. Brian is correct. This is even. Yes, ma'am. To the front office? Yeah, do you need a pass for that? Or I doubt though. If they do, all right, you won't. Last one. Even, odd, or neither. Let's see. Negative x. Again, I doubt you're gonna get these. These are called rational functions. This is more of an algebra 2 thing. Even though I have seen this before in algebra 1, but I don't think you're gonna get these. Okay, so the negative x squared becomes positive x squared. The 3 stays the same. On the bottom, this becomes negative x to the 3rd and then plus x. Okay, it's definitely not going to be even because the signs aren't the same. Huh? Would it won't be negative? Yeah, I'm trying to think of a special rule for rationals. Because actually, if it was like, for instance, like let's say it was only this, right? It would actually be odd because even though we haven't distributed, This would make the first term negative. That would make the second term negative. And then they would actually change signs. But now since there's two terms on the bottom, well, just for fun, we have some extra time. Let's see what this looks like on a graph. Let's see what the graph will tell us. My instinct would be to say neither, but I just want to make sure that I'm not falling into an exception here. You don't have to worry about, I can't see this showing up on a final exam. Let's see. Now, if it is like, okay, so again, we're sure it's not even, right? But if it is odd, and I show you a graph of it, where should it be symmetrical? What type of symmetry should it have? It should have origin symmetry. So let's see. So that's the graph of it there. Origin symmetry would have it be symmetrical. Is that one of my kids having a party, or is that one of them? Guys, it's rude to have a party and not invite everybody. I think it's a kid. Whoever has is that you that's blasting the? Does look odd, doesn't it? Here, let's do the test with the points. We can test it with points, right? Let's do the test with points. We're not sure. So 5, 0.233. So what else should be there? -5, -0.233. Yeah, it looks like it's gonna be odd. Is there any that is? Let's pick a point like around here. Fine. -1.331. So let's see what happens at positive 1.331. Was it 331? Was I reading it wrong? Let's see. -1.322. And then we'll check if that's -4, -1. So 1.322. Yeah, 4.03. Yeah, it actually ended up being odd. It actually ended up being odd. Just don't worry about those. I can't see those showing up. I'm gonna ask some of the other algebra ones why that showed up on this thing.